Welcome to your all-inclusive course for learning Kubernetes. In this course, you'll learn what Kubernetes is, why it's so popular, as well as how to bring up your own Kubernetes cluster and launch a containerized application. You'll also learn all about the logical components of Kubernetes, such as namespaces, pods, replication sets, services, deployments, and configuration maps. We're going to have an overview of how all these key components work together and how you can manage them using Kubernetes manifests. Once you have a solid understanding of the components of Kubernetes, we'll be getting into how you can launch and manage your own Kubernetes cluster using Minikube. For those of you that don't know what Minikube is, it allows you to bring up or recreate Kubernetes clusters in a single command. It's also the recommended method in the Kubernetes documentation for getting started with learning Kubernetes. So whether you're training for a Kubernetes certification or just trying to get hands-on experience for a job, Minikube is going to be a huge help. But before we get into creating our cluster using Minikube, let's first discuss why Kubernetes is so important. For the past few years, software development has seen a major shift from monolithic applications to smaller containerized applications known as microservices. Container runtimes like Docker and Containerd were a good first step in running containerized workloads for enterprises, but as containerized workloads became larger and more complex, a standardized way to develop, deploy, and scale up applications was needed, and from this need, Kubernetes was born. Kubernetes is a portable, extensible platform for managing and orchestrating containerized workloads and services. It was originally designed by the engineers at Google under the project name of Borg, but it's now an open source project under the name of Kubernetes. A master node schedules container workloads onto worker nodes based on their requirements such as CPU, memory, or system architecture. Kubernetes uses manifest files in the form of YAML to create, modify, and delete Kubernetes resources such as pods, deployments, and services. In recent years, Kubernetes has become the industry standard for running applications. All major software companies are running workloads in Kubernetes. The need for developers and engineers that are experienced in Kubernetes has gone up exponentially. So if you're in the field of software development or IT operations, then there's no better time to learn Kubernetes than now. So let's get into it. The foundations of the Kubernetes cluster architecture is quite simple and consists of two key components. Master nodes, which make up the control plane, are responsible for the running state of the Kubernetes environment, and worker nodes, which run the containers in what's known as pods. Pods are a logical component of Kubernetes that we'll dive into in the next section, but for now, you can think of them as a group of containers that make up an application. When a pod is deployed to a Kubernetes cluster, it's the job of the master servers to find an appropriate worker server for them to run on, and it's the job of the worker servers to run the actual containers within the pod. So Kubernetes master servers are made up of four key components: the API server, the scheduler, controller managers, and etcd, which is used as shared storage between the nodes. The API server is the front end for the Kubernetes control plane. When you make any changes to Kubernetes using kubectl or the web GUI, you are talking to the kube API server. The kube scheduler watches for newly created pods with no assigned node, and selects a node for them to run on. Many factors are taken into account for scheduling decisions, such as resource requirements and policies. Kubernetes have many control managers which are responsible for the state of the cluster. It's the controller's job to move Kubernetes state towards what's known as the desired state. Finally, etcd is used to persist the Kubernetes cluster state. All cluster configuration data is saved to etcd. Worker nodes have the following components: a container runtime, the software responsible for running containers; kubelet, an agent that runs on each node in the cluster, responsible for making sure that containers are running in a pod; and kubeproxy, a network agent responsible for maintaining network rules for communication between your container pods. So in a nutshell, master nodes are responsible for taking care of the state of your Kubernetes cluster, and worker nodes are responsible for running the actual containers. Now let's have a look at the logical components of Kubernetes that make this all work, such as pods, deployments, ReplicaSets, services, volumes, ConfigMaps, and how we manage those components using a combination of kubectl and manifest files. Pods and manifests. Pods are the smallest deployable unit that you can create and manage in Kubernetes. A pod is a group of one or more containers with shared storage and network resources and a specification for how to run the containers. Like any other Kubernetes resource, pods can be created manually through kubectl CLI commands. However, they are best managed through manifest files. Here's an example manifest file of a single container pod running an image of Nginx. All manifest files for Kubernetes resources are built in a similar fashion, requiring the following fields: the API version, which specifies the version of the Kubernetes API you're using to create the object. This is in place for backwards compatibility, so Kubernetes knows when this manifest file was created, which version of Kubernetes it was created for. Next we have kind, which specifies the kind of object you're creating. In this case, it is pod. After that, we have the metadata fields. These fields help uniquely identify the object. In this example, we are just specifying the name, but you could also add additional information such as labels and namespaces. And finally, we have the spec, where you specify your desired state for the object. The fields in the spec will be dependent on the kind of resource you are creating. In our case, we are creating a pod, so we specify the container settings for the pod, such as the image and open ports. So pods are a logical grouping of containers defined by a Kubernetes administrator. If you're familiar with Docker Compose, they feel very similar to that. Although pods are the bread and butter of Kubernetes, they are rarely deployed directly. Instead, we use another abstraction for managing pods, known as deployments. Deployments and replica sets. As mentioned, pods can be created and managed individually. However, in the real world, this is rare. It's much more common to use a higher level abstraction known as deployments to manage your Kubernetes applications. Deployments configure replica sets that allow pod scaling, as well as can be used to manage seamless updates to pods through rollouts and rollbacks. When you create a deployment, it creates a replica set for that pod version. It's the job of the replica set to monitor pods and make sure that the current replicas in the cluster always matches the desired replica count. So say, for example, if our desired replicas is 3 and a pod dies on one of our nodes, bringing our current replicas down to 2, the replica set will make sure that a new pod is brought online on one of the nodes as soon as possible, bringing our replica count back to 3. Rollouts and rollbacks are another great feature of deployments, which we'll see in the lab portion of this video, which allow you to seamlessly update your pods as well as roll back to an older version if need be. Services. Services are the next major logical component of Kubernetes you need to understand. Services allow communication to your pods by exposing them as a network service, load balancing incoming connections to pods that can dynamically shift throughout a Kubernetes cluster. The service selects pods based on the criteria specified by its selector. In this example, selecting pods that have the label of the tier of frontend. Notice how the traffic only gets routed to pods with the same label. The pod with the label tier backend does not receive traffic. Now let's have a look at a manifest for a service that we'll be creating later on in this video. As you can see, it's set up similar to the previous manifest files we had a look at. We set the API version, object kind, and metadata. Beneath those fields, we have the spec configuration, which has 3 key parts: the ports, the selector, and the type. The port section is pretty simple. Here we just specify the protocol and port we want the service to send traffic to our pod on. In our case, it's web traffic, so we have TCP port 80 configured. After the port section, we have the selector. The selector is how the service knows which port to forward traffic to. In our case, it will be pods that have their labels set as app, my web app, and their tier set to frontend. Finally, we set the type to load balancer, which will allow clients external to the Kubernetes cluster to access the service. There are 5 types of Kubernetes services that you can choose from, but the most common type you're likely to run into in cloud environments is load balancer. So a common setup in AWS environments is to direct your traffic to an AWS Elastic Load Balancer and then forward that traffic to your Kubernetes service, which in turn load balances your traffic to your Kubernetes application. This is similar to how we're going to configure our application, but instead of using a cloud load balancer, we're going to expose the service using the Minikube service command. Now we are almost at the practical portion of this course where we will be bringing up our own Kubernetes cluster and creating the resources we have discussed. But before we do that, let's discuss volumes, config maps, and secrets. In Kubernetes, by default, files in a container are considered ephemeral, meaning once the container or pod is replaced, the files are gone. Obviously, a lot of applications require some sort of persistent file storage, and Kubernetes volumes are the solution to that problem. At its core, a volume is a directory which is accessible to the containers in a pod. The data in the volume will persist no matter what happens to the containers. Whether they crash, get restarted, or removed, the data will remain. The medium that backs the volume depends on the particular volume type used. With Kubernetes, there are many different volume types to choose from, and a lot of them are dependent on your infrastructure or the cloud environment that you're in. This is a topic that is deserving of a video of its own, so for now, let's move on to config maps and secrets. Config maps and secrets are another way to expose data to containers in your pod. Both config maps and secrets store data the same way, using key-value pairs. The difference is config maps are meant for plain text data, while secrets are meant for data that you don't want exposed. Since the data that we will be using is not sensitive, we'll be creating config maps and mapping them to our pods, but you should know that creating secrets and exposing them to the pods is done the exact same way. Congratulations! It's been just over 10 minutes and you now have foundational knowledge of Kubernetes. Now to cement that theory to your mind, it's time for you to get some practical experience by creating your own cluster and deploying and customizing a Kubernetes application. In the next section of this video, I will show you how to get a cluster started with Minikube and deploy all the components we have discussed. We will start with a simple application and then move on to one that we can customize ourselves. You may want to watch the next portion of this video twice, the first time watching to understand the concepts, and then again following along and running the commands on your own Minikube cluster. If you have any questions or run into any issues, make sure to check the comments below, as it's likely others may have run into similar issues. Okay, so getting a Minikube cluster up and running is actually really simple. All you have to do is head on over to their website and go to Get Started, and there's going to be installation commands for your operating system. So I'm on Windows, but I'm actually doing this through a Linux virtual machine that I just installed through the Windows Store. So I ran the Linux command to get Minikube installed. So you'll just need to do the same and choose the commands for your operating system. Now the next thing it tells you to do is run this Minikube start, but a lot of you might run into issues when you're doing this. I'm using Docker as my virtualization platform for Minikube to run on. So I actually needed to head on over to this drivers page, and then I went to Windows, Docker, and then I made sure to start it up using this start Docker driver, or you could just do this. And basically what this is doing is it's just telling Minikube to use Docker. So I'll just take this command and throw it in here and then do a Minikube start. And I need to type it right, so I'll do Minikube start, and now my cluster should start. And I got another error here, and that's because Docker Desktop is not started. So in order to use Docker to run your Minikube cluster, you actually need it started. So I'm going to go ahead and start that right now. And Docker Desktop is started now, so I'm going to go ahead and rerun that command, and my startup should run. Now, if you're getting any issues with the Minikube startup, just go ahead and Google the error, and someone's likely run into the same issue, and you should be able to troubleshoot it that way. Okay, so it looks like my Minikube did start successfully here, and just to verify that, you can do a Minikube status, and this will tell you if your Minikube is running properly or not. You can also just go Minikube, and it'll tell you all the Minikube related commands. The key ones that I use is start to start the Minikube cluster, stop to stop it, and then delete when you want to delete the cluster and start a new fresh one. There's also this dashboard command, which allows you to run a Kubernetes dashboard. So let's have a look at that one right now, actually. And I'm going to specify the parameter --URL. And this should give us a link to our Kubernetes dashboard that we'll be looking at throughout this course. All right, so that did take a minute or two, but it looks like it's up right now. And when I go to it, you can see that this gives you the Kubernetes dashboard. Now, this isn't going to be something that you manage Kubernetes with, really. We're going to be using manifest files to create and manage all our logical components of Kubernetes. But this is a really good way to go in and just sort of explore the Kubernetes environment. So right now there's not really much to see because we haven't created anything, but we're going to come back here at the end once we launch our application and get some containers going, some deployments, some services, and just have a look at how they look in the dashboard. And it just gives you that much more insight into how Kubernetes works. Okay, so now that you have a Kubernetes cluster started using Minikube, the next tool that you need is Kubectl, which is used to administrate Kubernetes clusters. So the best way to get it is to look up the official documentation on how to install it for your operating system. I'm on Linux, so it consists of a curl command and moving the binary to a specific location. So I'm going to run those two commands now. And this should be very similar whether you're doing it on Windows or Linux. And now that I have it installed, I can test it out just by going kubectl version. And you can ignore this deprecation warning. We can see here that we have a version of 1.24.3. Now you're probably on a way newer version than me, but that's fine. Everything should work out okay. What you want to do is just make sure that the version you have is consistent with your version of Minikube. Now, when it comes to Kubectl, there's two things that you should know about. The first one is most people actually alias Kubectl to the letter K, and this just saves you a lot of time from actually writing out the entire Kubectl command. So this is the first thing I always do is in my shell profile, I set up an alias. I'm just going to do a quick one here. And you can see I've done this command before since my autocomplete is coming up here. But basically what I do is I just alias K to Kubectl. So I'll just run that. And now if I went K version, it would give me the version of Kubectl. So I can run any Kubectl command just using the letter K now. Okay, so we have Kubectl installed and we have set an alias to the letter K. The next thing I want to show you is how you can actually view or modify your Kubectl configuration. So to have a quick look at your Kubectl configuration, you could just go Kubectl, or in our case, just K, config, view. And this is going to dump out your configuration for your Kubectl CLI application. Now, in our case, everything has been set to Minikube, and basically what happened was when we did our Minikube start, Minikube went into our Kubectl config and set itself up. Now, if you wanted to connect to like a real live development or production cluster of Kubernetes, what you would want to do is modify your Kubernetes config file and add that information in there. So the location of this configuration file is your home directory .kube config. And that's actually a file, so I can't CD there. But if I'm in here, you can see the file is this config file, and if I just cat it out, you're going to see the same thing that you saw when we did kconfig view. So that's the configuration of Kubectl. Let's have a look at some of the commands. So I'll clear the screen here, and if I just go Kubectl and hit enter, it's going to give us all the commands that are available here. Now, looking at this can actually be quite intimidating when you're just getting started, but it's actually pretty simple on how to actually use these commands. There's only really a few that you're going to be using when you're getting started, which are the Kubernetes get command, the describe command, the create and apply, as well as a few others. I'm going to make sure to have a list of the key commands that you use when administrating Kubernetes and deploying applications to Kubernetes, and I'll have that in my GitHub in the description below. So if you want to just take that and have it up next to this tutorial, you can follow along and use those commands. But let's actually get into using some of these commands. So the first one that I'll go over is Kubectl Cluster Info. And basically this just tells us information about our Kubernetes cluster. We can see that the Kubernetes control plane is running at this IP address and this port, and the core DNS is running at this location. So Kubectl Cluster Info is just a quick way to get a look at your Kubernetes control plane address as well as your core DNS. If you wanted more information, you could run your Kubectl Cluster Info dump. So another key command that you should know is how to get the nodes running in a Kubernetes cluster. So I'm just going to go get nodes. And since this is Minikube, it's just a single node cluster. We just get the output of Minikube here, and then we can see the status of ready, as well as how old this cluster is. Now, if I wanted to get more information about this node, I would go describe node, and then the name of the node, which is Minikube. And this gives us all the information that we would ever need to know about this Kubernetes node. You can see it gives us system information, CPU count, and just about everything that you would want to know about the Kubernetes node. So really good for troubleshooting here. Another thing that you may need to do when administrating Kubernetes clusters is sometimes you'll need to take them down. And the way to do this is to cordon the cluster. So you can do this by doing cordon Minikube. And now if we go get nodes, we can see that Minikube is ready, but scheduling is disabled. Now there's a second part to this that you would need to do in a production environment, which is actually draining the pods from the cluster before you go and, patch it or restart that node. We'll be doing that at the end of this video, since we'll actually have pods running on it, and then I'll be able to show you what's actually happens. But if we wanted to bring our node back online, say we patched it and it's ready to go, what we could do is uncordon the cluster. So we would just take this command, and instead of saying cordon, we'd go uncordon. And then if we go get nodes, we can see that this node is ready. So I think that's a good start to the basics of cluster administration. Let's get into namespaces and actually creating Kubernetes resources. So now that you know how to administrate Kubernetes clusters, let's have a look at namespaces and how we can create and manage them. So if you haven't already, go ahead and clone my GitHub repository, because I have a couple manifest files there that we're going to use. But to look at Kubernetes namespaces, all you need to do is use your Kubectl utility to go kubectl get namespaces. Namespace, actually. And you can see here that there is about 5 namespaces by default. The bottom 4 here are used by the Kubernetes control plane, so you should just ignore them. But the top one here is the default namespace. And by default, this is what Kubectl is going to use unless you set your default namespace to something else. Now, the default namespace is where all your Kubernetes resources are going to get created unless you specify a different namespace. Now, if you want to create a new namespace, you can easily do that just by using the Kubernetes create command. I mean the Kubectl create command. And you just go Kubectl create namespace. And you can create one called prod, one called dev, and one called test if you want. And then just go get namespace. And you should see that you have your 3 created here. Now let's go ahead and say you wanted to delete one. All you would have to do is use Kubectl, delete namespace, and then the namespace that you want to delete. So we're deleting our prod namespace here, and I'm actually going to recreate it using a manifest file. So I have a manifest file in this solution directory. So let's go in there. Sorry, it's not actually in the solution directory. It's in the namespaces directory, of course. So go into the namespaces directory, and we can see a manifest file here. So let's have a look at this namespace manifest file. And you can see that it's pretty simple. It's very similar to the ones that we went over. It's got the kind, set as namespace. We're setting the API version, and then you have some metadata with some labels set there. So namespaces are very simple. Basically, they only need a name, and then optionally you can add a label. So this manifest file looks good to me. And if you wanted to create this, you would just go k create -f and then the file name. And then we can see that the namespace was created. And if we do kubectl get namespace, you can see that it was right there, just created 9 seconds ago. So that's a pretty simple introduction to creating and managing resources with manifest files. Manifest files are definitely the preferred method of administrating Kubernetes resources. Now, if we wanted to get more information about these namespaces, we can use our describe command. So just do kubectl describe and then the namespace name. And you actually need a resource type before you put the namespace name. So we'll go k describe namespace prod. And you can see they gave us all the information in regards to our namespace. Another key thing to mention here is that namespaces can actually enforce quotas and resource limits, and that's one of the main reasons people actually use namespaces. They might want a specific department to only have access to a certain amount of Kubernetes resources, so namespaces are a great way to do that. So now that we have the basics of namespaces down, let's get into creating and deploying a simple Kubernetes application. So we're going to start off by doing a kubectl get pods. So you can do kubectl get pods, and you can see that no resources are found in the default namespace. Now you can do the same commands. I'm going to use my alias k here. So k get pods, and then you can see that it's auto-completing because I've done this before, -n dev. And basically what this is going to do is this is going to check the dev namespace for pods. So you can see there, no resources found in the dev namespace. So when you're using a namespace that is not the default, you're going to need to specify the -n parameter. And there's also a command that you can do to set your current namespace using the kubectl config command. I'm not actually going to enter this, but I'm just going to put it in so you guys can see it. It's just kubectl config set context --current --namespace, and then you can do dev or set it back to default. Whatever you want to call your namespace. I'm just going to work in the default namespace for now. All right, so let's create our first deployment, and let's actually create one in the default namespace as well as the development namespace. So there's a hello world container application that you can use directly from Kubernetes. So I'm just going to copy and paste a command here, and you guys can run the same. So basically it's this kubectl create deployment, and then hello-node, and then it specifies this image here, which is the basic K8 echo server. So I'm going to create that. And now when I go kubectl get pods, you can see that we have a pod running, and this is the default namespace. Now if I were to check the dev namespace, you can see there's nothing running there yet. Unless I rerun this command and then specify that the namespace I want to run it in is in dev. And now when I do kubectl get pods namespace dev, you can see that there's pods there. And then when you do the default one, you can see that we have one pod running there as well, and it's got a different name. Now another thing you can do is kubectl get pods --, I think it's all namespaces. And you can see all the pods running in all namespaces. Here's the two that we created up here. All these other ones down here are basically just running the Minikube and Kubernetes cluster, so you can ignore those. But this is a good way to see all pods running in all the namespaces. Now, another good command that you should know here is the Kubernetes events command. So now that we have some pods running, it's good to do kubectl get events. And then you can run all namespaces, or let's just do the namespace of dev. And I'll adjust my screen here. And you can see that basically everything that the Kubernetes cluster did is in this events buffer. And then if you read through these events, you can see when it happened. So 86 seconds ago, 85 seconds ago. So you can see that it pulled the image and created the container and then scheduled the pod and set up the deployment. So this is a good way to troubleshoot your Kubernetes cluster. Again, if you did like -- all namespaces, you're going to get everything that's happening in your Kubernetes cluster. So a lot of information there since we have like the Kubernetes dashboard running and all the API services running. So usually you want to specify this one to a specific namespace. So that's the Kubernetes events, but how do you actually access the application on this pod? And you can't actually access it from the outside directly. What you need is a service in front of this pod so you can access the service, and then the service can load balance connections to the containers in those pods. So let's go ahead and create a service. I'll clear the screen here. And we're going to use kubectl expose, and I've run this command before. So basically expose deployment hello node, and then I'm going to set the type to load balancer and then the port 8080, and I'm going to do this to the dev namespace. We can see that a service was created. If you go kubectl get services, you can see that only this Kubernetes one exists. And again, that's because it's getting the services for the default namespace, not the dev namespace. So I need to specify the dev namespace here. I just did. And there you can see that this load balancer hello node exists. Now there's one additional step to access this application, and that is to actually forward connections to this load balancer. Now if you're in a cloud environment, you wouldn't need to do this step. You would instead do whatever is native to that cloud environment. In AWS, you'd be using an AWS like Elastic Load Balancer. But since we're doing this on Minikube, what we can do here is just open up a new connection in a new tab, and we're gonna run Minikube service, and we want to get this service name that we created, so our hello node. So we're going to go Minikube service hello node, and this may take a minute or so to run. And again, I'm getting an error, not in the default namespace. Let's set a namespace here, and there we go. We can see that it exposed our local host IP to this port. So if we head on over there, and I'll bring the browser over, you should see something like this. So it's basically just a really simple echo back server. This is just a good way to verify that your Kubernetes pods are getting created correctly and you can access them. Now, this application isn't very exciting, just echoing back a little bit of information isn't that useful. Let's go ahead and create our own application and scale it up in Kubernetes. Okay, so now that we're familiar with Kubernetes and doing a simple deployment using the hello node, let's go ahead and deploy a containerized web application that I've put together for us. So I'm going to pull over Visual Studio Code and just go over the code that's available in the description below that you can use as well to deploy the application. And I'll just go over the folder structure here. So underneath the solution folder, I have all the versions of the manifest file that we're going to go through. We're going to iterate through this list, do version 1, v2, v3, v4, and just add more and more Kubernetes components to our application. And I'll be going over how these components work. The next part is the Docker app. You actually don't need this portion since the Dockerized container is on Docker Hub and you guys can just pull it down from there. But I just have it here for informational reasons if you want to go through and have a look at how this application works. There's a Docker file here. The Docker file here is how I built the Docker container, and then this app Python file is just our simple Flask web server. And you can see that it's just a very simple web server. Basically, it's got one route, and if you go there, it's just going to echo back the server name. So it's got get host name. And then there's a couple other things here, ways to customize the application. Basically, it's just taking in environment variables, and you can do a custom photo, you can change the font color, you can change the background color. The Docker file puts in these environment variables, but I'm going to show you how you can actually override these environment variables using Kubernetes configuration map. And this is a very common thing that you're going to have to do when you're deploying Kubernetes applications. You're going to be feeding them configuration maps and feeding in, environment variables, different volumes, secrets, things like that. So I'll show you how to customize this application once we get it up and running and scaled and everything. So let's have a look at underneath the solution folder at the version 1 of the application. Now, this template was just taken off the Kubernetes website, and I customized it to how I want my deployment. And as a Kubernetes administrator, that's basically what you're going to be doing as well. It's very rare that you go and type all these lines out, so I'm not going to make you watch me type out these lines. Just basically go ahead, copy and paste this in, and if you want to customize your own application, you just change these parameters. So let me go over these parameters so you have a good understanding of how they work. So if you want to customize your own deployment after you do this deployment with me, then you can do that as well. So again, at the top, you have the API version. This is just for backwards compatibility with different Kubernetes versions. Basically, it lets Kubernetes know which version of the API this manifest file was created for. The kind is deployment. Now, what we're going to be doing here is actually deploying a Kubernetes pod, and that pod is going to hold our containerized application. And the reason we're using deployment here is because that's the way you're going to do it in the real world. You're not going to go and create a manifest file for a pod. You're going to create a manifest file for a deployment, and that deployment is going to control your replication controllers and your pod. Now, underneath this metadata field, you could customize the name to whatever you want it to be, and this is just going to help you when you do your kubectl describe deployments. You're going to be able to see the deployment name there. And then for labels, this is going to be pretty important as well. Basically, labels is how we organize our Kubernetes applications. Basically, these labels can be whatever you want them to be. These are pretty common ones that you'll see. You see like app, and then you can give your application a name. And for tier, you can do like front end, back end, whatever you want it to be. So hopefully that makes sense. It'll make more sense as we go through the labels and how labels are used to select. But basically, for every Kubernetes resource that you create, you're going to want a label on it just so you have it better organized and you can use things like selectors. The next portion of the manifest file we have here is the spec, and it's actually broken down into two components. The first component is the replication controller, and the second component, everything underneath the template, is the template for the pods that you want to run. So the first portion is very simple. Basically, we say how many replicas of the pod we want running. And basically what Kubernetes is going to do is it's always going to make sure that at least one instance of the pod is running. Now, if you set this to something like 5, 50, or 500, then that's how many pods it's going to try to run. We'll keep this as 1 for now, but I'll show you later how we can scale up our pods just by changing this number. And then the next section here is the selector, and it's going to select everything that matches these labels. So for our deployment, we just want to make sure that these labels are the exact same as the ones in our pod template, which you can see they are. Now, underneath the pod template, it's very simple. You have the labels set here, and then you have the spec of the pod. And within the pod spec, we have our container set. So this is a single container pod, and I just gave it a name called my container. Again, you can change this to whatever you want. And then underneath we have the image, and I just have this set to DevOps Journey 1 / my web app because I have my image hosted on Docker Hub. So Kubernetes is going to see this. It's going to go up to Docker Hub, pull down the image to Kubernetes, and then the pod will start the container using that image. Now the next thing here is the ports. And we're just setting port 80 for some basic web traffic. So that's a pretty simple deployment manifest. Let's go ahead and go into Kubernetes and create this deployment. All right, so back in the terminal here, I'm underneath the solution folder, and you can see that we have all versions of our application here. And if I just cat out the v1, you can see exactly everything that we had in VS Code. So the way to apply this to Kubernetes is to use the kubectl apply command. So we'll do that, kubectl apply, and I want to specify version 1 of our YAML file. And you can see the output we get here is the deployment has been created. So to check on the deployment, we can go kubectl get deployment. And there you can see that our deployment was created 12 seconds ago. Now deployments also create the replica sets and the pods. So let's check on those. And we'll go get replica set. And you can see that has been created. And then if you go get pods, you can see that the pods have been created. Now, if you wanted any additional information about any of these resources, you could describe them. So you could go describe pods and then specify the pod name. So let's copy and paste that. And it gives you all the information that you would need to know about the pod. Let's do describe my deployment. So deployment, my deployment. And then you can see everything about the deployment. So if you need more information or just want to learn more about anything about these resources, use the describe command. Let's have a look at deleting these resources using the manifest file. So that's just as simple as creating them. We'll just go kubectl delete, specify the file name, and we'll go v1.yaml. And you can see the deployment was deleted. If we go get deployments, there's no more deployment. Replica set. There's no replica set for my deployment anymore. And if we go get pods, you can see the pod still exists, but you can see the status changed. It was running before, now it says terminating. So Kubernetes saw that the deployment no longer exists, so it's terminating the pod. So that's a basic Kubernetes deployment lifecycle, the most basic one that you'll see. You can get more involved with it with rolling updates and scaling up the replica set. We'll get a little bit into that later on, but let's have a look at the version 2 of our manifest file where we implement a service load balancer. So I'll pull it up in Visual Studio Code since it's a little easier to read. And you can see, if you're familiar with the YAML format, this is actually 2 YAML files just stuffed into one. And the way you can do that is just with these 3 dashes, which basically signify the end of a YAML file. So our old version 1 of the YAML file is down here, and then we have this new Kubernetes resource, the service load balancer, up in this section. Now, if you wanted to, you could separate this into 2 different YAML files and then apply them that way. But I find when you have simple applications like this, it's kind of nice just to stuff everything into the same manifest file and just modify everything in there. So that's what we're doing right here. Everything in the version 2 file is the same for our deployment, so we haven't changed anything there. We've just added this service load balancer. And at the top, you can see it's just the basics, set the kind to service and give it a label. And then at the bottom, it's split up into 2 sections in the spec. You have your ports section and the selector. So basically the port section is how to send the traffic to the pods. So we want to send traffic to the pods on port 80 using TCP, and then the name, you can have the name whatever you want. I put Flask here, but HTTP would make sense as well. Here we have the selector, and basically this is how the load balancer knows which pods to load balance the traffic to. So it's basically going to look at all pods that have these labels and then send the traffic to those. So down here, we can see our pods have those labels. So this load balancer service is going to send the traffic to our pods. Let's go ahead and apply this manifest. We'll just go kubectl, apply, and instead of v1, we'll go v2. And you can see that it was created, and my deployment was created as well. If you didn't delete the last deployment, then it should have just updated. But since we deleted our old deployment, it just created them new instead of updating them. Hopefully that makes sense. But let's have a look at our service, since that was the new resource created. Actually, we can check on our pods first. Yeah, our pods are running. Now let's have a look at our service. So we'll go get services. And you can see that my web app is running. Now, if you want to send traffic to this, it's going to be the same way as we did before with the Echo server. We need to do the Minikube command, and it'll forward traffic to this load balancer. And again, if you're in a cloud environment, you're going to be using your cloud provider solution to forward traffic to your Kubernetes load balancer service. So I'm going to open a new window here, and then I'm going to go Minikube service, and this is going to be the service name, which I forgot. So let's go get services. It's my web app. My web app. So I'll put that in. It may take a minute for you guys, but once it's up, you should be able to get to this URL. And you should get this website. So this is the basic website that my container is delivering. And we're going to actually customize this using configuration maps coming up later in this video. We'll be able to change the title as well as this image if you wanted to, and the background and everything. Now, here at the bottom, you can see that it is actually echoing out the pod name. And this is pretty cool for our container, because what we're going to do next is we're going to scale up our pods, and then we're just going to refresh this web server, and we're going to see how the traffic is load balancing to these Kubernetes pods. So let's have a look at version 3 of our application, which scales up our pods. Okay, got version 3 open, and it actually looks like I have a configuration map in here as well as scaling up the pods. So let's customize it and scale it up right now. So underneath the pod configuration, the only change I made here was changing the replicas. So now it's going to run 5 instances of the pod. And then up here, I have the configuration map. So the configuration map configuration is pretty simple here. Basically, just set the kind to configuration map, give it a name, and then set some data. So we're just going to be pushing in environment variables. Now, if you want to, you can customize this to whatever you want. So this is changing the font color to white, and this is changing the background color to sort of like a dark gray. If you want to use your own colors, go ahead and change this to whatever you want, as well as changing the custom header to whatever you want as well. Now, actually, in our container, we need to point to this configuration map to actually get it. So I actually did add some additional parameters other than just replicas in this version. You can see that we're feeding environment variables from the configuration map. So let's go ahead and apply this here. Now we'll go kubectl, apply v3. And we can see our configuration map has been created. Let's have a look at our pods. And you can see we got a lot of different pods here. And I'm actually not sure why we have so many. Let's troubleshoot this. So that's a little strange. It created 10 even though we only specified 5. I'm thinking that maybe the deployment and the configuration map sort of got created at the same time. So when the pods tried to come up, the configuration map wasn't ready. So I think maybe that's why. Maybe someone in the comments below can confirm if they think that's the reason for it. But nevertheless, you should have at least 5 pods running now. So if you go OK, get pods again. So it looks like everything sort of cleaned up itself. And we have 5 pods of my deployment running. Now, if we go into our actual web application and just refresh the page, you can see that we're getting the dark background with the white text, and it says customized with ConfigMap. So our application has been customized. Now, one thing I want to go over here that's going to save you guys a lot of time when working with config maps is you should be treating your configuration maps as unmutable objects. And basically what that means is once you create a configuration map, don't update that same configuration map, because what's going to happen, let me just pull up the code here. What's going to happen is if you created, say, a new configuration map and then changed something here, we'll change this to DevOps journey. Basically, what's going to happen here when you apply this is the configuration map gets configured, but the pods don't know that it changed. And if you go OK, get pods, you can see that they're still running. They've been running for a few minutes here, but they don't know to restart. And if we go into our page and refresh, you can see that up here that it hasn't changed to my new title of DevOps Journey. And the reason for this is because the pod doesn't know that the configuration map has been changed. So back in VS Code, and the way I update configuration maps is I'll change this information here, which we've already done, but I'll increment this version number. So now we have 2 configuration maps, and then I tell the pods to point to that new configuration map. So I'll go ahead and do that. Go here, clear the screen, make it a little more readable, and then K apply v3 YAML. And now you can see that my configuration map v.1.1 was created, and the deployment is configured as well. So if we do K get pods, you can see it's cycling through the pods, and when we go back to the actual page and refresh, you can see that the title has updated. So hopefully that makes sense. It's a good thing to know when you're actually doing this in production environments. You know, a lot of people will just update the old configuration map and then they start pulling their hair out wondering why the application isn't showing the changes. Now, the final thing I want to talk about is something that you'll want to do for your Kubernetes applications, and that is to set the amount of resources that the pods can consume. So we'll pull up version 4 of our configuration. I have specified some resources, and these are the resource constraints, and it's pretty simple to break down. You have the requests and the limits. So the requests is basically what the container is going to request as a minimum from the Kubernetes nodes, and then the limit is like how much the container is actually allowed to use at the very most. So basically, this is your minimum, and this is your maximum. And the reason why this is so important is your software might use all your resources. I used to do some web development, and I actually deployed an application, and the resources on this application were not constrained. And then there was a bug in the application where it would basically loop forever and just consume all the memory on the host, and since there was no limit, it just ate up all the resources on the node. So one of the benefits of Kubernetes is you can sort of compartmentalize your applications and make sure that, they don't interfere with your entire infrastructure, this one poorly programmed application consuming all the CPU and memory. So that's basically it. Just to go into the specifics here, basically what this is saying is use 16 megs of RAM and use 50 milli CPUs, which is half a CPU. And for our maximum, use 128 megs of RAM and use up to 1 CPU. So let's go ahead and apply this. So we'll go k apply v4. And you can see something happened here on my screen. It actually updated my old v1 version of my config map here. It's not really going to affect anything, but just keep in mind, whenever you're applying these Kubernetes configurations, it's going to apply everything in that manifest file. But if we want to see those constraints, we could just go k. You could describe the deployment or the pod. Let's describe the deployment. You can see this has the pod template, and the requests and limits are there. And then this would show exactly the same if you were to describe the pods. Now, some other really important things that you guys are going to want to know is some troubleshooting information for this. So how do you get logs from your containers? It's actually pretty simple. You can use the kubectl log command. So we'll go kubectl logs. And there's actually quite a few different ways you can do this, but I like to specify the label. So I'll go app equals my web app. And I actually need to specify -L for labels. That's why that command did not work. And there you can see it just printed out all the logs from all my pods that are running. Now, if I wanted to actually follow along, I could do -F, and now it's going to follow along. I actually haven't sent much web traffic since this deployment started, so there's not a lot of GET requests. But let's go here, change that over there, and move this here, and just start hitting F5. And now you can see that whenever I send web traffic over, the container logs are populating with that information. So a really good troubleshooting tool is using kubectl logs. Now, another thing with deployments is doing actual rollouts. So I'm going to Control-C out of here, clear that out. And if you go kubectl, rollout, and let's just hit enter, you can see all the different available commands over here. Basically, what if I wanted to restart all my pods? I could just go kubectl rollout, restart, deployment, my deployment. And now you can see that this deployment is restarting, meaning that all the pods are going to be restarting. So if we go k get pods, you can see that all the old ones were terminated and all the new ones are already up and running. So pretty quick. If you wanted to restart all your pods, that's the way to do it. Now, say I wanted to do some maintenance on this server, like patch it or restart it, you could do what we did earlier, which is to cordon the node, but you would actually also want to drain the pods off of this node. So let's go ahead and do that. I'm gonna do kubectl cordon Minikube, and then let's do kget nodes. And you can see that the node is ready, but scheduling is disabled. Basically what this is saying is if there's any new pods that need to start running, this node is not going to accept them and it's not going to run those pods. So that's the first step. And the next step is to drain the pods. So I'm going to paste this command in and just describe what it does. So basically it's saying kubectl drain Minikube. And then I have this additional ignore daemon sets true. This is because this is like a single Minikube cluster, and it would try to stop all the cube system pods, and it would send a bunch of errors. So we're just going to not stop those, and then we're going to force. Now we're getting two warnings here. The first one is that Minikube is already cordoned. That's not really a warning. Basically, it's just saying the drain command does the cordon for you, so you could skip the cordoning and just do the drain. The other thing here is the error, and basically it's saying it's not going to get rid of these pods because it would delete the local storage. So we wouldn't get this error if we use something like volumes. But since these containers do not persist data, we can just delete the empty data. So we'll just add that flag there. And you can see that all our pods are getting evicted. And if I just pull up another prompt here and go get pods, you can see that everything is terminating, and it's actually trying to schedule the new ones, but they're pending since this node is cordoned and it's not going to schedule any more pods. Now, if you wanted to bring this node back online, all you would have to do is go kubectl, uncordon Minikube, and if you go get nodes, you can see it's back and ready. If you go get pods, you can see the pods are up and running again. All right, so that was quite a bit of Kubernetes. I hope this video was helpful to you. If you have any questions or you want to see any more concepts of Kubernetes, please leave a comment below and I'll try to make a video in regards to that. If you're interested in DevOps or software development, go ahead and check out the other videos on my channel. And if you would like, subscribe as well. Thanks again so much for watching, and I hope to see you all in the next video.